two galaxies move towards each other. There is no explosion, no roar, but the universe changes forever. This audiobook invites you to discover the violent beauty of galactic collisions, colossal encounters where billions of stars, gas and dust intertwine like in a choreography guided by gravity. Far from being a senseless chaos, these mergers give rise to new stars, deform space, and reveal the hidden threads of dark matter. What happens when two galaxies merge into one, and what fate awaits the Milky Way in this cosmic game of inevitable encounters? Galaxies are like stellar communities, each with its own personality and unique characteristics. There are spiral galaxies, reminiscent of a whirlwind of bright lights, and elliptical galaxies, which appear calmer and more homogeneous, like a vast cloud of stellar dust. Additionally, there are irregular galaxies, which defy any classification and seem to be a chaotic mix of young and old stars. This diversity is what makes the study of galaxies so intriguing and relevant in astronomy. So what happens when these cosmic communities meet? The answer to this question is one of the most exciting phenomena in the universe: galactic collisions. Imagine two cities that, instead of growing in isolation, decide to unite in a cosmic embrace. What changes occur in the structure, culture, and life of those cities? Similarly, when galaxies collide, they undergo a radical transformation that can give rise to new stars and planetary systems. These collisions are not rare events. In fact, they are quite common in the vastness of space. Over billions of years, galaxies have been approaching and moving away from each other, like dancers on a cosmic stage. Each encounter brings the opportunity to create something new, but it can also generate chaos. What would happen if two large galaxies collided? The gravitational forces at play are colossal, and the outcome can be dazzling. One of the most intriguing questions we can ask is, what happens to the stars that find themselves in the path of these collisions? Contrary to what one might think, stars rarely collide with each other due to the enormous distances that separate them. However, the effects of the collision can be devastating for the interstellar medium, the space between stars where gas and dust form new stars. When galaxies merge, a kind of stellar rebirth also occurs. Clouds of gas are compressed under the influence of gravity, giving rise to new stars that are born in a spectacle of light and color. This makes galactic collisions a driving force of cosmic evolution, a process that not only transforms galaxies but also the very fabric of the universe. Of course, not all galactic mergers are the same. Some are more violent, while others may be gentler, like a hug between old friends. The nature of the collision depends on many factors, such as the size and shape of the galaxies involved. And this is where a fascinating concept comes into play: dark matter, a form of matter that we cannot see but that exerts a significant gravitational influence on the structure of the universe. This phenomenon leads us to reflect on the fate of our own galaxy, the Milky Way. Did you know that it is on a collision course with the Andromeda galaxy? This merger will not occur in the near future. But the fact that we are in the same cosmic dance as another galaxy raises intriguing questions about how our sky and our place in the universe will change. Scientists have been studying these phenomena for decades, using computer simulations to predict the behavior of galaxies during collisions. These simulations are like a virtual laboratory where they can observe what happens without having to wait billions of years to see the results. Each model provides a new perspective on how galaxies intertwine and evolve. As we delve deeper into the study of galaxies and their interactions, we also begin to see how these collisions can impact our own planet. Although we are millions of light years away from galactic events, the history of our universe is intertwined with that of these enormous structures. In the end, we are all part of this vast cosmos, and each collision, each merger reminds us of how interconnected we are. The beauty of galaxies and their dynamics leads us to explore not only science but also the culture and mythology that have emerged throughout history. Galaxies have been a source of inspiration for numerous myths, works of art, and literature. What makes such a distant and abstract phenomenon resonate so much in our imagination? In conclusion, galaxies and their collisions teach us about the nature of the universe and our place in it. Each encounter between these immense stellar structures is a reminder that the cosmos is in constant change, full of beauty and chaos. As we continue to explore and study, we get a little closer to understanding the mysteries that surround us. So keep your eyes on the sky, because you never know what cosmic wonders are happening in this vast space we call home. Galaxies are vast universes in themselves, composed of stars, gas, dust, and dark matter floating in space. But what exactly is a galaxy? In its most basic form, a galaxy can be thought of as a huge community of stars and other cosmic components held together by gravity. However, not all galaxies are the same. There are different types, each with its unique characteristics. Spiral galaxies, for example, resemble a disk with arms that curl outward like the tentacles of an octopus. In contrast, elliptical galaxies have a more rounded shape, similar to a sphere or an egg. Finally, irregular galaxies lack a defined shape, as if they were toys scattered in a messy room. Each type of galaxy has its own way of shining. And this diversity is part of what makes the universe so fascinating. But what are these wonders of the cosmos made of? Galaxies are primarily formed by stars, which are spheres of hot gas that shine with their own light. However, they are also filled with gas and dust that are not visible to the naked eye, but are crucial for the formation of new stars. Additionally, there is a mysterious component known as dark matter, which does not emit light or energy but has a significant gravitational effect on how galaxies behave and group together. The classification of galaxies is not just a curiosity. It is also fundamental to understanding how they formed and evolved over time. Since the Big Bang, galaxies have undergone a process of growth and change, and these categories help us study and understand their history. By observing the different shapes they take, we can infer aspects of their past and future evolution. So how did galaxies form in the first place? In the early moments of the universe, everything was chaos and energy. Over time, gravity began to act on matter, pulling small particles toward a few larger ones. Over millions of years, these accumulations of matter cooled and grouped together, forming the first galaxies. Imagine a large whirlwind of sand in the desert. As the wind blows, the sand gathers into mounds, forming unique shapes. This process of grouping is similar to how galaxies have formed throughout the history of the universe. Galaxies are not solitary islands in the vast cosmic ocean. Rather, they are part of a dynamic fabric where gravity plays an essential role. The gravitational forces acting on galaxies are like a cosmic dance. Each star, planet, and cloud of gas moves in response to the forces surrounding them. This movement is not always predictable and can lead to interesting interactions between galaxies. For example, when two galaxies come close to each other, they begin to influence one another. This interaction can result in an impressive spectacle where stars are pulled and reconfigured as if they were in a cosmic dance. Gravity not only holds galaxies together but also pushes and pulls them, creating a constantly changing environment. There are many galaxies in our universe, and some of them are destined to collide. But what does a galactic collision really mean? When two galaxies meet, it is not like a car crash on a road. In space, the stars within the galaxies are so far apart that they rarely collide directly. However, the gravitational forces acting on them can cause drastic changes in their shapes and structures. As these galaxies approach each other, the gas and dust they contain may begin to interact, often triggering a burst of star formation. It's as if, in the midst of the collision, cosmic fireworks ignite, creating new stars in a visual display of light and energy. This process of creating new stars is one of the most fascinating outcomes of galactic collisions and shows how chaos can give rise to beauty in the universe. Each type of galaxy has its own evolutionary path, and their interactions during collisions can shape their future. Spiral galaxies, for instance, may transform into elliptical ones after a collision, while irregular galaxies may acquire new shapes. This process of transformation is a reminder that the universe is in a state of constant change. Nevertheless, we cannot forget the importance of dark matter in all of this. Although it is invisible and we cannot detect it directly, its influence is fundamental. Dark matter acts as a skeleton that supports galaxies and allows them to interact. Without this mysterious substance, galaxies would not have the structure we observe today. It is as if dark matter is the glue that holds all the pieces of the galactic puzzle together. Thus, when we look up at the sky, we not only see stars, but also the history of the formation and evolution of galaxies. Each one tells a unique story, full of changes, collisions, and transformations. And as we continue to explore the universe, each discovery brings us a little closer to understanding not only how galaxies formed, but also our own place in this vast cosmos. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Galaxies are fascinating structures that shape our universe, but have you ever wondered how these vast collections of stars, gas, and dust form? To understand this, we need to go back in time to the moment when everything began to take shape in the primitive universe. In those moments, just after the Big Bang, matter was distributed quite evenly, like a fruit smoothie before you mix it well. But gravity, that powerful force that keeps planets in orbit, began to work its magic. Imagine you have a bag of marbles. If you drop them on the floor, some will cluster together and form piles. This is how gravity started attracting small amounts of matter. These groupings grew larger, as if they were magnets attracting more and more marbles. And so the first structures began to form, giving rise to what would eventually become galaxies. But where does all that matter come from? In the early universe, there were primarily hydrogen and helium, the simplest and most abundant elements. As gravity gathered more and more of these elements, dense clouds began to form, collapsing under their own weight. This collapse not only led to the creation of stars, but also initiated the formation of galaxies. It's like making a snowball. The more you roll it in the snow, the bigger it gets. Over time, these gas clouds began to spin, just like a figure skater spins faster by pulling their arms closer to their body. The rotation of these clouds accelerated as they contracted. This rotation gave rise to rotating disks that are characteristic of many spiral galaxies. But not all galaxies are the same. Some form differently, creating elliptical or irregular shapes. As galaxies grew, they became more complex. Star clusters developed, regions of star formation emerged, and they were often accompanied by dark matter, a mysterious substance we cannot see but that plays a fundamental role in the structure of the universe. Dark matter acts like scaffolding, helping to hold galaxies together and guiding their formation. Dark matter is a bit like that friend who is always in the background of photos, invisible and not the center of attention, but essential for the picture to make sense. Without it, galaxies wouldn't have enough gravity to stay cohesive, and they would crumble like a sandcastle in the rain. An intriguing aspect of galaxy formation is that the process often does not occur in isolation. Galaxies can influence each other, merging or interacting through their gravitational forces. This cosmic dance has been a crucial part of how the galaxies we see today have formed. The story of galaxies is, therefore, a tale of growth, interaction, and change. As these structures formed, so did clusters of galaxies, creating enormous networks that we can observe in the current universe. Some galaxies developed in solitude, while others joined in groups, forming cosmic communities. But what about their future? As galaxies continue to evolve, the process of collision and merging remains an essential part of their story. The way galaxies form and change over time is an endless cycle, where each collision and each merger gives rise to new stars, planets, and potentially new forms of life. The formation of galaxies is a reminder that the universe is dynamic and constantly changing. From those humble beginnings to the majestic structures we can observe today, the story of galaxies is one of wonder and awe. Each galaxy is a chapter in a cosmic book that continues to be written, and each star that is born is a new page added to that narrative. So the next time you look up at the starry sky, remember that each point of light you see is part of a galaxy, a story of formation, collision, and interaction that dates back to the dawn of the universe. Galaxies are not just collections of stars, they are monuments to creation, witnesses to cosmic history, and bearers of the secrets of the vast universe that surrounds us. What makes galaxies move the way they do? Is there a cosmic dance that orchestrates their movement in the vast universe? To understand galactic dynamics, it is essential to think of gravity as the conductor of this symphony. Gravity, that invisible force that keeps us glued to the Earth, also acts on much larger scales, connecting galaxies in a cosmic web. When we look at the night sky, what we see are stars and some galaxies. But behind that beauty lie complex gravitational forces. Just as planets orbit around the Sun, galaxies also have their own movements, influenced by the gravity of other galaxies and by dark matter that we cannot see but which makes up a significant part of the universe. Isn't it fascinating to think that what we cannot see can be so influential? Dark matter acts like a skeleton in the cosmos, holding the structure of galaxies together and allowing them to remain united. Although we cannot see it directly, its presence is inferred through its gravitational effects. Imagine you are at a party, and although you don't see all the guests, you can feel the energy of the crowd. That's how dark matter manifests in the universe, influencing the galaxies around it. As galaxies move through space, they also experience complex interactions. These interactions can be subtle, like a brush, or they can be violent, like a collision. How is it possible for two gigantic collections of stars to come so close without immediately colliding? It all comes down to speed and gravity. As one galaxy moves through space, its gravity attracts other galaxies, creating a kind of game of attraction. Think of two ice skaters gliding toward each other. If they approach at high speed, they might meet in a spectacular spin, but if they come close slowly, they might just cross paths without a significant collision. The same happens with galaxies. Their speed and the force of gravity determine how they interact with each other. Moreover, galactic dynamics are not static. Galaxies can change course and speed due to the influence of nearby galaxies. This phenomenon is known as gravitational perturbations. When one galaxy passes close to another, its gravity can distort the shape of both. It's as if they are in a cosmic dance where the proximity of one galaxy can cause the other to spin unexpectedly. The interaction between galaxies can also lead to changes in their shape and structure. When two galaxies approach, their spiral arms may appear elongated and twisted, as if they are stretching under the tension of gravity. But what happens when these galaxies finally meet? This is where the dynamics become even more exciting. Galactic collisions are not rare events. In the vast universe, it is quite common for galaxies to cross paths and merge. These mergers are moments of transformation, where the energy of the interaction can give rise to new stars and solar systems. Can you imagine that, in the chaos of a collision, new bright stars emerge dancing in space? The effects of galactic dynamics extend beyond the visible. When galaxies interact, interstellar gas and dust are disturbed, which can lead to the formation of new stars. Thus, amid the chaos, new worlds come to life. Each collision is an opportunity for creation, a spark of life in the vast emptiness of the cosmos. Dynamics also play a crucial role in the evolution of galaxies over time. As they interact and merge, galaxies can change their classification. A spiral galaxy may become elliptical after a violent merger, and these transformations are part of the eternal cycle of the universe. It's as if galaxies are artists constantly changing their style, adapting to the circumstances of the moment. In the context of our own Milky Way, it is astonishing to think about the role that galactic dynamics have played in our history. The Milky Way has interacted with other galaxies throughout its life, and those encounters have shaped its current structure. Every star in our sky has a story to tell, woven into the web of galactic interactions. Galactic dynamics also help us understand the future. Predicting how galaxies will behave in the future is essential for astronomy. With each discovery, scientists can refine their understanding of how gravitational forces shape our universe. Who knows what new wonders will be revealed as we delve deeper into these cosmic interactions? In summary, galactic dynamics is a complex and fascinating dance that shapes our universe, from gravitational attraction to spectacular collisions. Each movement tells a story of transformation and creation. As we continue to explore the cosmos, we discover that the universe is not only vast, but also a place where interaction and dynamics are the key to its beauty and complexity. Galaxy collisions are some of the most spectacular and enigmatic events in the universe. But what does it really mean for two galaxies to collide? In simple terms, a galactic collision occurs when two galaxies come so close that the gravity of each begins to attract the other. It's like two large magnets drawing near, and instead of repelling each other, they join in a cosmic embrace. But how often do these collisions happen? The universe is a vast space in constant motion. Galaxies are not static. In fact, they move throughout the cosmos at impressive speeds. Some of them approach each other and eventually end up colliding. It is estimated that over billions of years, large-scale galactic collisions occur. But why does this happen? The answer lies in gravity. This force, omnipresent in the universe, is what pulls galaxies towards each other. As they get closer, the gravitational force intensifies and eventually, the encounter occurs. One fascinating aspect of these collisions is that they are not simple encounters. In reality, they are complex processes that can take millions of years. When two galaxies meet, their structures become deformed. Imagine two masses of modeling clay pressing against each other. As the galaxies collide, their stars, gas, and dust mix. This not only causes changes in the shape and structure of the galaxies, but it can also generate new stars within them. How is this possible? When galaxies collide, the gas and dust they contain are compressed due to gravity. This compression can lead to the formation of new stars, as if the collision were a spark igniting a fire of newly born stars. So, although it may seem chaotic and destructive, a galactic collision is also an act of creation, where the end of one galaxy can mean the birth of many stars and solar systems. Now, what happens with the colliding galaxies? Not all galaxies are the same. Some are large and massive, while others are small and weaker. The interactions between these galaxies can vary greatly. Imagine a large bowling ball hitting a tennis ball. The heavy bowling ball has a much greater effect on the tennis ball. In the galactic context, this means that larger galaxies tend to dominate the collision process. This phenomenon can result in the creation of a larger galaxy than the two originals. Galactic mergers can also trigger extraordinary phenomena. During these encounters, galaxies can experience bursts of star formation, where thousands of stars are born in a short period of time. This is known as a starburst and is one of the most exciting outcomes of galactic collisions. It is important to mention that not all galactic collisions result in mergers. Some galaxies may simply pass by, like two cars crossing at an intersection. However, the universe is filled with galaxies that come so close that they are eventually attracted to each other. And that is when the real magic happens. Throughout the history of the universe, countless galactic collisions have occurred. In fact, it is believed that most of the galaxies we see today have gone through at least one collision in their lifetime. This leads us to wonder, what does the future hold for our own galaxy, the Milky Way? The answer is fascinating, as it is scheduled to collide with the Andromeda galaxy in about 4 billion years. This encounter will not only change the appearance of both galaxies, but will also influence the formation of new stars and solar systems. When talking about galactic collisions, we cannot forget dark matter. This mysterious substance, which does not emit light or energy, plays a crucial role in how galaxies behave in space. Dark matter acts as a glue that holds galaxies together during these collisions. Without it, the universe would be a very different place, and galaxies might disintegrate instead of merging into a beautiful cosmic spectacle. In the realm of science, the study of galactic collisions has advanced significantly. Astronomers use telescopes and computer simulations to observe these events and better understand their dynamics. Through these tools, we can see what happens in the universe, even if it is billions of light years away. But how does all this look from our perspective on Earth? Often the idea of galactic collisions may seem distant and abstract, but in reality, they are part of the cosmos's history. These interactions not only teach us about the evolution of galaxies, but also remind us that the universe is in constant change. So the next time you look up at the starry sky, think about the galaxies that are in motion and the cosmic dance unfolding around us. Galactic collisions are a reminder that amid all the chaos, there is also beauty and renewal. In this vast and enigmatic reality, each collision tells a unique story, a story that is constantly developing in the grand theatre of the universe. What happens when two galaxies meet in the vast universe? The answer to this question takes us into a world of wonders and surprises that radically transform these enormous cosmic structures. The collision of galaxies is not just a crash. It is an event that triggers a series of dramatic changes, not only in the galaxies themselves, but also in the stars and planets that inhabit them. To understand these effects, we must first delve into the fascinating process of how a galactic collision can lead to the formation of new stars. When two galaxies collide, intense gravitational interaction occurs. Imagine two clouds of gas and dust that, as they approach each other, begin to intertwine. This cosmic dance causes an increase in gas density in certain regions, creating areas where pressure and temperature are sufficient for stellar fusion processes to begin. This is how, amid the chaos of the collision, new stars are born. But how does this happen exactly? The answer lies in the primordial fuel, hydrogen. Hydrogen, the most abundant element in the universe, is essential for star formation. During a galactic collision, the gas from both galaxies is compressed, generating dense molecular clouds. In these clouds, conditions become ideal for hydrogen to clump together and, through gravity, form new stars. Thus, while two galaxies collide, a celestial spectacle unfolds, where young and bright stars emerge from the ashes of chaos. However, not everything is that simple. Galactic collisions can be violent and chaotic. What happens to the stars that already existed in these galaxies? Some of them may be expelled at incredible speeds, hurled into intergalactic space, while others may become trapped in the new resulting structure. This process, known as galactic interaction, transforms the composition and shape of the galaxies involved. But what does this mean for their inhabitants? Collisions not only create new stars, but can also trigger the formation of planetary systems. When new stars form, it is likely that rotating disks of material will form around them, where planets may eventually be born. Thus, amid the roar of the collision, new worlds could be coming into existence, perhaps with conditions suitable for harboring life. The idea that a galactic collision can lead to new homes in the universe is truly astonishing. However, not everything is rosy. The violence of these collisions can lead to the destruction of entire stellar systems. Some stars may be dragged toward the center of a merging galaxy where gravity is immense, and their fates become uncertain. Imagine being a stellar system caught in the midst of a cosmic war where gravitational forces play a crucial role in determining your future. As galaxies merge, their cores also interact. These dense areas, where most of a galaxy's mass is concentrated, can experience dramatic changes. In some cases, supermassive black holes at the centers of each galaxy may begin to dance around each other, creating a cosmic ballet that could culminate in the formation of an even more massive black hole. The way a galaxy's core transforms during a collision is a fascinating field of study. Furthermore, during these encounters, spectacular phenomena can be observed, such as the formation of elongated and filamentous structures of gas and dust. These structures, called tidal tails, are the result of gravity pulling materials from the galaxies. The beauty of these tails is a reminder that even in chaos, the universe can create extraordinary forms. Galaxies can also change their shape during a collision. A spiral galaxy may lose its characteristic arms and become elliptical, while an irregular one may acquire new shapes. This change in galactic morphology is a testament to the power of the gravitational forces at play. Can you imagine watching a galaxy transform before your eyes? It is a sight to behold. It is fascinating to think about how galactic collision events occur over billions of years. The cosmic timescale is so vast that what may seem cataclysmic to us is just a chapter in the history of a galaxy. The galaxies colliding today have been on collision courses for eons, and their history dates back to the origins of the universe. This cycle of creation and destruction is an integral part of the fabric of the cosmos. The collision of galaxies also offers us a window into the history of the universe. By studying these collisions, astronomers can learn more about the formation and evolution of galaxies. Each collision is a unique event that provides clues about how the universe has developed over its existence. Thus, each galactic crash is, in a sense, a narrative of cosmic history, a story written in the stars. In summary, galaxy collisions are complex events involving the creation of new stars, the destruction of others, and the transformation of the galaxies themselves. They show us that, in the universe, beauty and chaos often go hand in hand. The next time you look up at the sky, remember that in the vast universe, galaxies are constantly in motion, colliding, merging, and giving birth to new stars and worlds. The collision of galaxies is undoubtedly one of the most fascinating spectacles in astronomy and a testament to the grand and mysterious power of the cosmos. Galaxies in collision are like enormous cosmic dances, a ballet of matter and energy that transforms the landscape of the universe. But what really happens when two galaxies meet in this type of collision? To understand it, we must first imagine what these gigantic structures are like. Galaxies are communities of stars, gas, and dust, bound together by gravity, and when they merge, the result is an astonishing spectacle of chaos and creation. As two galaxies approach, they begin to feel mutually attracted by their gravity. It's a bit like two magnets coming together. At first, everything seems calm, but as they get closer, they start to interact in surprising ways. The stars, which appear to be very far apart, begin to influence each other, and their movement becomes more complex. Sometimes stars are pushed into new trajectories, and some may even be ejected into interstellar space. Can you imagine being a star speeding toward an unknown destination? During this process, the matter within the galaxies does not behave uniformly. Clouds of gas and dust, which are the basic ingredients for forming new stars, are compressed and heated, creating a kind of stellar factory amid the chaos. When galaxies collide, waves of star formation occur. So, what happens at this moment? Thousands of new stars are born, shining brightly in the vastness of space. These stars are mostly young and hot, illuminating the sky in a way that has never been seen before. But what about the galaxies themselves? As they merge, their shape changes drastically. Spiral galaxies, with their rotating arms, may lose their defined structure and transform into elliptical galaxies, more compact and diffuse. This change is not just superficial, it also affects the internal dynamics of the galaxies. The galactic cores may merge, creating an even more massive core that can influence the movement of the stars around it. Imagine the heart of the galaxy beating stronger and faster, attracting everything around it with its powerful gravity. Galactic mergers are not rare events. In the universe, these collisions occur regularly, and astronomers have found evidence of numerous mergers throughout cosmic history. Some of these mergers have resulted in enormous and bright galaxies, while others have created smaller and less luminous galaxies. So how do we know this really happens? Thanks to modern technology, scientists can observe these events even millions of light years away, using telescopes that capture different wavelengths of light. An interesting phenomenon that occurs during galactic mergers is the appearance of supermassive black holes at the centers of galaxies. When the cores of the galaxies merge, these black holes can also join together, creating an even more massive black hole. Can you imagine the gravitational force of such a black hole? It is so intense that nothing, not even light, can escape its pull. This can have a profound impact on the evolution of the resulting galaxy. As the merger progresses, galaxies may experience episodes of intense activity in their cores. This translates into the emission of large amounts of radiation, creating what are known as active galactic nuclei. These nuclei can shine more brightly than the entire combined galaxy, becoming cosmic beacons that astronomers can study to better understand the physics behind these phenomena. Galactic mergers also impact the interstellar medium. The interaction of the galaxies can trigger shock waves that compress clouds of gas and dust, which in turn can lead to the formation of new stars and planetary systems. It's as if an explosion of energy brings new stars to life that, in the future, could host planets and potentially life. Who knows how many civilizations might be forming in these new worlds? Meanwhile, it is important to remember that galactic mergers are not events that happen overnight. They can take billions of years to complete, and the final result is a galaxy that, although different, remains part of the fabric of the universe. As these galaxies evolve, so does their environment. Gravitational interactions continue, and the cycle of star formation and destruction never stops. In summary, galactic mergers are a crucial part of the evolution of the universe. They are events that not only change the fate of the galaxies involved, but also impact the interstellar medium and can lead to new stars and planetary systems. In this cosmic dance, every movement is significant, and every collision tells a story of transformation and renewal. The beauty of the universe lies in this constant change, where chaos and creation intertwine in a spectacle that challenges the imagination. Who can say what wonders the future holds in this immense and mysterious cosmic dance? What is the fate of our galaxy, the Milky Way? As time progresses, a spectacular encounter with the Andromeda galaxy is approaching. This cosmic event, which may seem straight out of a science fiction movie, is actually a natural phenomenon that will occur in about 4 billion years. But what does this collision really mean for us and for our galaxies? When thinking about a galactic collision, many might imagine a violent crash, like two cars in the middle of a road. However, in the vastness of space, things are a bit different. Galaxies are primarily composed of empty space, so even though the Milky Way and Andromeda are on a collision course, the real question is, what will happen to the stars and solar systems within them? First, it is important to understand that the stars in these galaxies are very distant from each other. When these two gigantic structures of gas, dust and stars meet, most of the stars will continue on their path without hardly noticing. So how is it possible for two galaxies to collide and not be completely destroyed? The answer lies in gravity, which acts like a cosmic magnet, pulling the galaxies together and shaping their destiny. As they approach, gravitational forces will begin to play a crucial role. Imagine two magnets coming close to each other. Their opposite ends attract strongly, while their similar ends repel. Something similar happens with galaxies. Gravity not only attracts them but also distorts their shapes, creating spectacular tails of stars and gas in a process that could take billions of years. And what about dark matter in this scenario? Dark matter, which makes up a large part of the universe's mass, cannot be seen directly, but its presence is fundamental in the interaction between galaxies. It acts as an invisible framework that helps support the structure of galaxies. Without it, galaxies could not form such complex and fascinating collisions. Isn't it intriguing how something we cannot see plays such an important role in our existence? During the collision between the Milky Way and Andromeda, not only will there be a merger of galaxies, but it is also likely that new stars will form. The gas and dust that are compressed during the encounter can lead to the creation of new stars, illuminating the sky in ways we have never imagined. This process is a natural cycle of birth and death in the universe. Imagine a grand cosmic dance where stars swirl and intertwine, creating new constellations in the process. But what will happen to our solar system? Its location is likely to change, but the chances of Earth colliding with another star are very low. So, while the galactic landscape will transform, it is possible that our life as we know it will not be so affected. In this context, the Milky Way and Andromeda will join in a cosmic embrace that could last millions of years, resulting in a new galaxy, sometimes called Milkdromeda. This new galactic home could have an elliptical shape, different from the spiral we know today. Imagining the future of the universe is like looking towards a horizon filled with infinite possibilities. As these events unfold, astronomers of our time are racing to better understand how these collisions work. Observing galaxies at different stages of collision provides us with clues about what will happen to the Milky Way and Andromeda. Modern telescopes are like time machines, allowing us to look back in the history of the universe and see how these interactions have shaped the cosmos. The galactic clash between the Milky Way and Andromeda is just one of many in the vast universe. Each galaxy has its own story and its own interactions. Throughout cosmic history, galactic mergers have been responsible for the creation of many of the structures we see today. The beauty of the universe lies in its constant evolution and the changes that occur over eons. Finally, it is fascinating to think about how these gigantic galactic encounters not only affect stars and galaxies, but also influence life on Earth at a more abstract level. The matter that forms our world and our lives comes from stars that have lived and died in past collisions. So in a sense, we are all part of this cosmic dance, reflecting on the future of the Milky Way and Andromeda. It is easy to get caught up in the wonder of the unknown. In the vast theatre of the universe, each collision, each merger reminds us that everything is connected, that the stories of the galaxies are also ours. And although time may distance us from those events, there will always be a thread that connects all living beings to the vast cosmos that surrounds us. What if I told you that most of the matter in the universe is invisible? That's right, dark matter is one of the greatest mysteries of modern astronomy. Although we cannot see it directly, its influence is crucial in how galaxies interact with each other. Especially during collisions. How can something we don't see have so much power? Let's unravel this mystery. Imagine a party where all the guests are dancing, the music is playing, the lights are flashing, and everyone is moving in harmony. However, there is a group of people who are not in the center of the dance floor, but rather at the back, gently pushing the crowd. Although they are not the center of attention, their presence is essential for the dance to work. This is how dark matter acts in the cosmos. It doesn't shine like stars, but its gravity guides the movement of galaxies. Dark matter makes up approximately 95% of the total matter in the universe. Can you imagine? We only see a small fraction of what truly exists. When galaxies collide, dark matter plays a crucial role in dictating how that collision will unfold. As two galaxies approach, dark matter causes a kind of gravitational dance. But what does this mean for the galaxies involved? During a collision, the dark matter of each galaxy is attracted to the dark matter of the other. This causes the galaxies to deform and change shape, as if they were two water balloons pressing against each other. In the end, the interaction of dark matter can determine whether the galaxies merge or simply slide past one another. Gravity is a main actor in this cosmic drama. But how do we know that dark matter exists? Despite its invisibility, astronomers have found clues in the behavior of galaxies. For example, when we observe how galaxies rotate, we notice that the stars on the outer edges move at much higher speeds than they should if we only considered visible matter. This suggests that there is more mass at play, hidden from our view, and that extra mass is dark matter. During galactic collisions, dark matter not only affects how galaxies move, but it can also influence the formation of new stars. When galaxies come close, the gravity of dark matter can cause the gas and dust in the galaxies to compress, creating the ideal conditions for new stars to be born. It's like squeezing a balloon as you do so. The air concentrates in a smaller area, creating pressure that can lead to something new. There are different types of dark matter, each with unique characteristics. Cold dark matter, which moves slowly compared to light, is believed to be the most common. This form of dark matter is fundamental for the formation of large-scale structures in the universe. On the other hand, hot dark matter, which moves faster, may have played a role in the early universe, but its influence is much less significant today. Galaxies do not only form a cosmic ballet due to their own mass, but they are also deeply influenced by the dark matter surrounding them. When one galaxy approaches another, it feels as if they are in a kind of gravitational embrace where dark matter acts as an invisible glue that binds them together. But what happens when these two galaxies merge? This is where the story becomes even more interesting. Galactic merging, driven by the interaction of dark matter, can lead to the creation of giant elliptical galaxies. These are like the elderly of galaxies, having gone through many experiences and changes. In this process, dark matter not only helps form new stars, but can also influence the formation of supermassive black holes at the centers of the resulting galaxies. Reflecting on our own galaxy, the Milky Way, we can see how important dark matter is in our cosmic history. As our galaxy prepares to collide with Andromeda, dark matter will act as a conductor in this monumental event. The way both galaxies merge and evolve will largely depend on the gravitational interactions mediated by dark matter. But can we really come to understand dark matter? Scientists are working hard to unravel its secrets. Through experiments and advanced telescopes, they are searching for signs of this mysterious substance. Each discovery brings us one step closer to understanding how the universe works and our place in it. As science advances, dark matter remains an enigma. It reminds us that, although we may see only a small fragment of the universe, there is so much more to discover. The next time you look at the starry sky, think of the vast network of dark matter that connects all galaxies, influencing their destinies and the fabric of the cosmos. In summary, dark matter is the invisible backdrop that allows galaxies to meet, collide, and evolve. Although we cannot see it, its presence is felt in every corner of the universe. As we continue to explore the cosmos, each answer leads us to new questions, and the quest to understand dark matter is one of the most fascinating in the history of humanity. Have you ever looked up at the starry sky and wondered what happens in the heart of a galaxy? Sometimes galaxies are not just collections of stars and cosmic dust, they are like cities in constant motion. At the center of many of these cosmic cities are active galactic nuclei, which are true powerhouses in the universe. But what makes them so special, and above all, what happens to them during a galactic collision? Active galactic nuclei are regions at the center of some galaxies that shine intensely, much more than the rest of the galaxy. Imagine a neon lamp in the middle of a dark room. That's what they represent in the vast cosmos. But where does all that energy come from? Mostly it comes from a supermassive black hole located at the center of the galaxy. This black hole is not just a simple dark hole, it is a cosmic monster that can have millions or even billions of times the mass of our Sun. When a galaxy collides, the impact on the active galactic nucleus can be astonishing. The gravitational interaction can draw gas and dust toward the black hole, feeding it and making it shine with even greater intensity. It's as if the galaxy is throwing fuel onto the fire of its nucleus, intensifying its brightness. But what happens to the stars and planets during those chaotic moments? That's where it gets really interesting. During galactic collisions, many stars can be pushed outward due to the gravitational forces at play. It's like a group of people in a crowded room starting to move and push against each other, causing some to exit through the door. However, the gas and dust that are drawn toward the nucleus are also important for the creation of new stars. The pressure and temperature increase, and when the conditions are right, new stars can form in the process. This stellar rebirth is not always an orderly process. Collisions can generate shock waves that compress the gas, facilitating the formation of new stars, but they can also disturb them and cause them to destabilize. Sometimes it may seem like chaos, but amidst all that disorder, stellar life finds a way to emerge. Active galactic nuclei not only shine from the material they absorb, but they also emit radiation in the form of X-rays, visible light, and even radio waves. This makes them very powerful energy sources, capable of influencing their surroundings in many ways. Can you imagine what it would be like to live in a galaxy with such an energetic nucleus? The light it emits could be comparable to a lighthouse guiding cosmic travelers through the darkness of space. But it's not all brightness and splendor. The material that is absorbed by the black hole can be part of an endless cycle. As the black hole feeds, it can influence the evolution of the entire galaxy. A growing black hole can release jets of particles that extend through space, affecting the interstellar medium and the formation of new stars in nearby regions. Thus, a single active galactic nucleus can have a significant impact on its galaxy and its cosmic neighborhood. The interaction between active galactic nuclei and other galaxies also raises intriguing questions. Could a galaxy with an active nucleus infect another in a collision? The answer is yes. During these collisions, energy and material can be redistributed, and a less active galaxy could awaken and become more dynamic. It's as if one galaxy is waking up from a long sleep upon coming into contact with its more energetic neighbor. As astronomers observe these interactions, they realize that they are not just witnessing collisions, but they are witnessing a true cosmic ballet. Every movement and every interaction tells a story about the evolution of the universe. Observing these active galactic nuclei is like looking through a window into the past, revealing how galaxies have changed and adapted over time. However, despite all this fascination, many questions remain unanswered. How do these collisions affect life in the galaxies? And what will happen to our own Milky Way when it collides with Andromeda in billions of years? The study of active galactic nuclei and their behaviors during galactic collisions is not just an exercise in curiosity, but a quest for knowledge that could change our understanding of the universe. So the next time you gaze at the night sky, remember that in those distant galaxies there are active nuclei shining brightly, fueled by the chaos and beauty of galactic collisions. In the vast ocean of the cosmos, each collision is an opportunity for creation and transformation, and each star that is born carries with it the story of a constantly changing universe. Galactic collisions are fascinating events that have left their mark on the history of the universe, but what does this actually mean? How is it possible for gigantic structures made up of millions of stars, gas and dust to collide with each other? The answer takes us on a journey through time and space, where gravity plays a leading role. To understand the history of galactic collisions, we must begin to think of the universe as a vast and bustling ocean. In this ocean, galaxies are like ships navigating through invisible currents of gravity. Sometimes these ships get so close that unintentionally they end up colliding with each other. However, unlike a maritime accident, where the damage is immediate and visible, galactic collisions are processes that can extend over millions of years, slowly transforming the galaxies involved. A fascinating example is the story of the antennae galaxies, which formed from the collision of two spiral galaxies. You can imagine how two dancers on a stage move toward each other, twirling and intertwining their arms. In the case of these galaxies, their spiral arms intertwine, generating a cosmic dance that gives rise to new stars. Isn't it incredible to think that every time two galaxies collide, new stars are being created, as if the universe is constantly reinventing itself? As galaxies collide, they not only find themselves in a kind of cosmic embrace, but deep interactions also occur within them. In this process, the gas and dust that make up each galaxy are forced to mix and redistribute. Imagine a large salad where the ingredients are tossed together, forming a completely new mixture. Thus, galactic collisions can lead to an increase in star formation, which in turn can make those galaxies shine brighter than ever before. However, not everything is a fairy tale in the universe. Collisions can also have devastating effects. Just like a storm that ravages a landscape, a galactic collision can trigger the formation of supermassive black holes at the centers of galaxies. This occurs when matter concentrates in a point so dense that its gravity becomes irresistible. But what happens to the stars that were in the path of these collisions? Many can be expelled from their galactic homes, becoming nomads in the vastness of space. The story of galactic collisions is also intertwined with life itself in the universe. While some galaxies are destroyed or transformed, others may merge and create an environment conducive to the birth of new forms of life. This makes us wonder, how many times have our own galaxies gone through transformation processes before arriving at what we know today? An exciting aspect of galactic collisions is that they are not just unique events. They are part of a continuous cycle. Just like the seasons of the year where winter gives way to spring, galaxies also experience cycles of collision and merger. This means that the universe is in constant change, evolving in ways we are still trying to understand. In the history of the universe, there are significant examples of galactic collisions that have transformed the cosmic landscape. Astronomers have observed numerous cases where spiral galaxies have collided and merged, giving rise to what we now know as elliptical galaxies. But what about irregular galaxies? These are the rebels of the universe, those that do not conform to the norms and are often the result of chaotic collisions. It is fascinating to think that as we explore the cosmos, every image we see of a distant galaxy could tell a story of collisions and mergers, of chaos and creation. The light we observe today is the result of events that occurred millions of years ago. How many stories of collisions are hidden in the lights that shine in the night sky? The study of these collisions not only offers us glimpses into the history of the universe, but also provides clues about the future. With each collision, galaxies change, transform, and teach us about the processes that will shape our own cosmic future. What will happen to the Milky Way and Andromeda when they finally cross paths? The answer to that question reflects our own existence in the universe. As scientists continue to explore and discover more about galactic collisions, it becomes evident that these events are crucial for understanding not only the evolution of galaxies, but also the very fate of the cosmos. With each new investigation, we get a little closer to unraveling the mysteries of the universe and understanding our place within it. In summary, the story of galactic collisions is a narrative of transformation, creation, and chaos. It invites us to reflect on the dynamic nature of the universe and to appreciate the beauty that arises even from the most violent events. So the next time you look at the stars, remember that each twinkle could be the legacy of a galactic collision that changed the history of the cosmos. Have you ever stopped to think about the chaos and beauty that lie behind the backdrop of the universe? Galactic collisions are not just spectacular events, they are an essential component in the history of our cosmos. In the early universe, when everything was in its infancy, galaxies were like small bubbles floating in a vast sea of dark matter and gas. How did these collisions affect the formation of the universe as we know it today? Since the birth of the first stars, galaxies began to carve their own paths through a dense and turbulent cosmos. In that vast ocean of matter, galaxies were drawn towards each other by the force of gravity. Imagine a cosmic dance where each galaxy is a moving partner, spinning and drawing closer without a clear plan. In this context, collisions were inevitable, but what do they really mean? In the primitive universe, galaxies were much smaller and much closer to one another. Each collision was like an explosion of colors and shapes, where new stars were born from gas that was compressed due to gravity. In this process, galaxies did not just collide, they merged and fused, forming much larger and more complex structures. The result of these mergers was a constantly transforming universe, a place where creation and destruction coexisted in a delicate balance. What is the impact of these collisions on galactic evolution? Interactions between galaxies are not only spectacular due to their explosive nature, but they also influence the shape and content of the resulting galaxies. When they collide, galaxies can experience intense star formation. New stars are born from gas clouds that are compressed during the encounter, as if the universe were giving birth to new generations of bright lights. As galaxies merge, a fascinating phenomenon also occurs: the redistribution of matter. Have you ever seen how the ingredients of a salad mix when you stir it? Something similar happens in space. Colliding galaxies mix their gas, dust, and stars, creating a new cosmic landscape. This process not only transforms the structure of galaxies, but also affects the chemistry of the interstellar medium. Heavy elements necessary for the formation of planets and life are scattered throughout the universe. However, not all collisions are the same. Some smaller galaxies can be absorbed by larger ones, as if they were pieces of a cosmic puzzle. What happens to the dwarf galaxies caught in this game of gravity? Often they are stripped of their stars and gas, feeding their parent galaxies and contributing to their growth. It's as if the larger galaxies are devouring the smaller ones, absorbing their essence to become even more imposing entities. At the heart of these collisions lies an even more intriguing phenomenon, the formation of galaxy clusters. When multiple galaxies collide, they not only merge but can also come together to form massive groups held together by gravity. These clusters become the building blocks of the universe, where galaxies interact and evolve together, creating a complexity that goes beyond what we could imagine. As the universe expands, the galaxies that collided in their youth have left a lasting imprint on the cosmic landscape. Their history of encounters and mergers can be read in the shape and distribution of the galaxies we observe today. But how do we know all this? The answer lies in astronomical observations. Telescopes have captured images of galactic collisions, revealing details that help us understand how these interactions shaped our universe. At its core, galactic collisions are a reminder of the dynamic nature of the cosmos. Everything we see, from the stars in the sky to the planets we inhabit, is intrinsically linked to these cosmic interactions. What does this mean for us? It means that we are part of a constantly changing universe where life itself could be the result of collisions that occurred billions of years ago. The story of galactic collisions is a tale of transformation, a narrative that connects us not only with our past but also with our future. Could it be that every star we see in the sky is the result of an ancient encounter between galaxies? The answer is a glow of hope and possibility, a reminder that in the vast universe, even chaos can give rise to life. As we look to the future, it is exciting to think about how galactic collisions will continue to shape the destiny of the universe. As galaxies continue their cosmic dance, each encounter is an opportunity to create something new and amazing. In the end, we are witnesses to an eternal spectacle where the past, present, and future intertwine in a magnificent symphony of stars and galaxies. Galaxy collisions are events of astonishing magnitude, and while they often seem like cosmic catastrophes, they are actually catalysts for transformation. Imagine a vast space where galaxies, like enormous cities in the sky, move in a cosmic dance. But what happens when these cities cross paths? What effects do these collisions have on the galactic environment? Galaxies are not just clusters of stars, they are complex ecosystems that harbor dust, gas, and a variety of celestial objects. When two galaxies collide, it is not like a traffic accident on Earth where vehicles crush into each other. In space, the stars within these galaxies are so distant that, for the most part, they pass by without colliding. However, the gas and dust found between them are the true protagonists of this spectacle. As they approach, the gas is compressed, which can lead to the formation of new stars. Think of this as if you were preparing a soup. When you mix the ingredients, some begin to cook and release flavors. In the case of galaxies, the compressed gas heats up and forms new stars, thus creating a new cosmic menu. But how much impact does this really have on the galactic environment? The answer is much deeper than it seems. Galactic collisions not only affect the galaxies involved but also modify the interstellar medium surrounding them. As they interact, these large structures can unleash stellar winds, streams of gas that sweep through the surrounding space and affect other nearby galaxies. This is similar to a hurricane that drags everything in its path. The energy released can cause other gas formations to collapse and give rise to new stars in neighboring galaxies. And what about dark matter, this invisible component believed to make up most of the universe's mass? Plays a crucial role in these interactions. Although we cannot see dark matter, its gravitational effect is palpable. When two galaxies approach, dark matter can act as a kind of skeleton that guides how they move and deform. Thus, the collision becomes a cosmic dance where dark matter sets the rhythm and direction. Sometimes colliding galaxies can merge into a single one, creating a larger and more complex galaxy. This process is not instantaneous. It can take hundreds of millions of years. During this time, the galactic environment changes drastically. The trajectories of the stars are altered, and the overall landscape of space transforms. It's as if an entire city is in constant renewal, where old buildings are demolished and new ones rise. A galactic collision can also awaken the activity of supermassive black holes that reside in the centers of galaxies. When two galaxies meet, their black holes can attract surrounding material and, in doing so, release enormous amounts of energy in the form of radiation. This is comparable to a volcano erupting after being dormant for a long time. The resulting explosion of light and energy can be detectable millions of light years away. But what about dwarf galaxies? These small structures often undergo the most changes during collisions. They can be absorbed by larger galaxies or even trigger the formation of new stars in their vicinity. In this sense, dwarf galaxies are like small towns that, when absorbed by a large metropolis, contribute their culture and essence to the new environment. It is interesting to think about the long-term impact these interactions have on the universe. Galactic collisions are natural processes that have shaped the structure of the cosmos as we know it today. Without these interactions, the universe would be a much less dynamic and diverse place. Galaxies are not just in constant motion. They are in an eternal dance that creates and destroys, transforms and renews. Research on these collisions does not stop here. Scientists use computer simulations to model the effects of these interactions and predict how galaxies will behave in the future. These simulations allow us to explore scenarios that we could not observe directly. It's like having a time machine that lets us travel into the future and see how cosmic events will unfold. Moreover, through advanced telescopes, astronomers can observe galactic collisions at different stages of their development. Each observation provides new clues about the history of the universe and its evolution. These tools are like eyes that allow us to see the cosmic past and better understand our place in the vast fabric of space. Galactic collisions are a reminder that the universe is a place of constant change. In each encounter, there is an opportunity for the creation of new stars, the transformation of galaxies, and the emergence of new structures. Thus, although these events may seem chaotic, they are also an essential part of the beauty of the cosmos. In this vast stage, galaxies continue to dance, collide, and merge, creating a spectacle that invites us to marvel and reflect on our existence in this immense universe. Dwarf galaxies are like the small jewels of the universe, often overlooked but playing a crucial role in the history and evolution of larger galaxies. Who could imagine that these tiny groups of stars, gas and dust, would play such an important role in the formation of the cosmos's structure? In this section, we will explore how these smaller galaxies interact with their larger neighbors and how these interactions can have profound effects on the universe. To begin with, let's consider what dwarf galaxies actually are. They are groups of stars that contain fewer than 1 trillion stars compared to our Milky Way, which has hundreds of billions. Despite their size, these galaxies are rich in dark matter, the same substance that forms the invisible skeleton that holds larger galaxies together. This crucial component makes them more than just simple collections of stars. They are key players in the cosmic theater. An intriguing question is, how do dwarf galaxies relate to larger ones? Imagine a cosmic dance where dwarf galaxies orbit around the larger ones like satellites. As they get closer, they can be drawn in by the gravity of their more massive companion. This encounter is not always peaceful. Sometimes these small galaxies are torn apart and their stars are scattered into a new environment, enriching the interstellar medium of the larger galaxy. It is fascinating to think that many of the larger galaxies, like our own Milky Way, have accumulated stars and gas over time by eating dwarf galaxies. This process not only changes the appearance of the host galaxy, but also influences its future evolution. Can you imagine what it must be like for a dwarf galaxy to be absorbed? In a sense, it is as if they are leaving a legacy of stars that will continue to shine long after they have merged. The question arises, why are dwarf galaxies so common? In the vast universe, there are more dwarf galaxies than large ones. This is because in the early days of the cosmos, gas and dark matter clumped together to form these small structures. As the universe expanded and cooled, some of these dwarf galaxies managed to survive, while others merged and formed larger galaxies. Their number is a testament to the rich history of the universe. Some dwarf galaxies are so ancient that they preserve information about the primitive universe. These cosmic fossils can offer clues about what the universe was like billions of years ago. What secrets do they tell us? By studying them, astronomers can better understand the evolution of galaxies and the formation of large-scale structures. On the other hand, dwarf galaxies can also be home to surprising phenomena. Some exhibit bursts of star formation, where new stars are born at an accelerated rate. This raises an intriguing question. What triggers these explosions of activity in such small places? It serves as a reminder that even in the darkest corners of the universe, there is life and continuous change. It is often thought that dwarf galaxies are simple and uninteresting, but this could not be further from the truth. These small galaxies can be the stage for dramatic interactions and collisions that give rise to new stars. Just like in a careful choreography, dwarf galaxies move through space, sometimes colliding with their larger companions, creating a spectacle of light and life. Dark matter plays a fundamental role in the life of dwarf galaxies. How? As dwarf galaxies approach larger ones, the influence of dark matter can drastically change their trajectory. This mysterious substance, which makes up most of the universe, acts as a web that holds galaxies together, guiding their movements and often determining their fate. It is interesting to note that dwarf galaxies can also affect their galactic environment. When they merge or collide, they can trigger waves of star formation in the larger galaxy they interact with. This means that despite their size, they can be catalysts for significant changes in the cosmos. Isn't it amazing to think that a small group of stars can have such a large impact? The study of dwarf galaxies also allows us to explore the diversity of the universe. Not all of them are the same. Some are elliptical, others spiral, and some even irregular. Each type has its own story and unique characteristics. This leads us to reflect on the nature of galaxies themselves. They are a reminder that the beauty of the universe lies in its variety. As we can see, dwarf galaxies are more than just small galaxies. They are essential components of the universe, influencing the formation, evolution, and dynamics of larger galaxies. They teach us that, in the vast cosmos, even the smallest can have a profound and lasting impact, and that every star, no matter how tiny, has its own role to play in the symphony of the universe. So the next time you look up at the starry sky, remember that behind the bright constellations and vast galaxies, there is a world of dwarf galaxies, each with its own story to tell. On the grand stage of the cosmos, every star and every galaxy, regardless of size, contributes to the beauty and chaos of the universe. Have you ever stopped to think about how scientists can predict the behavior of galaxies during their spectacular collisions? To unravel this mystery, they turn to a fascinating tool: computer simulations. But how does this process work? First, it is important to understand that galaxies are extremely complex entities. They are made up of billions of stars, gas, dust, and interestingly, a large amount of dark matter. This dark matter, which we cannot see directly, plays a crucial role in how galaxies interact. Therefore, when creating simulations, scientists consider not only visible matter but also this enigmatic dark matter. Imagine you are playing a strategy video game where you have to build and manage your own galaxy. At the beginning, you have to decide how to distribute your resources. Similarly, in simulations, scientists must set the initial conditions. This includes the amount of stars, gas, and dark matter in the galaxies, as well as their speed and direction. The more precise these parameters are, the more realistic the simulation will be. Simulations are based on the laws of physics, specifically gravity. Through powerful algorithms, researchers can model how galaxies will move as they are attracted to each other due to their gravity. This is similar to how two dancers approach and move toward each other on a dance floor. Following the rhythm of an invisible music, scientists observe how the trajectories of galaxies change and how their structures deform during the process. One of the most intriguing questions that arise is, what happens to the stars during a galactic collision? Simulations help answer this by showing how, despite their proximity, stars actually have a very low probability of colliding with each other. This is because the space between them is vast. However, gravitational interaction can trigger the formation of new stars in regions where gas and dust are compressed, as if they were the ingredients of a cosmic recipe. Scientists can also observe something fascinating in their simulations: the merging of galactic nuclei. When two galaxies get close enough, their centers can join together, forming a new, more massive nucleus. This process not only changes the shape of the galaxies, but can also lead to a burst of activity in the galactic nucleus, as if a spark were igniting a campfire. But what does this mean for the future of the involved galaxies? The answer lies in the behavior of the supermassive black holes found at the center of many galaxies. During a collision, these black holes can come closer together and eventually merge, releasing a tremendous amount of energy in the form of gravitational waves. This is like two large ocean waves crashing together, creating an impressive spectacle on the water's surface. As scientists continue to develop their simulations, they can also explore different scenarios. They wonder, what would happen if a dwarf galaxy approached a larger galaxy? Simulations show that in many cases these dwarf galaxies are absorbed, as if they were small fish being swallowed by a larger fish. This not only affects the dwarf galaxy but can also alter the structure of the larger galaxy, adding new stars and gas to its composition. The beauty of these simulations is that they allow astronomers to see events that occurred billions of years ago. Through them, they can reconstruct the history of galaxies and understand how they have evolved over time. It is like reading an ancient book with stories of cosmic battles and alliances. But what about the accuracy of these simulations? There is always the challenge of balancing complexity and simplicity. Sometimes scientists have to make compromises, choosing which details are necessary to obtain meaningful results. This is a complicated but essential task for advancing our understanding of the universe. Moreover, computer simulations are not limited to predicting galactic collisions. They can also help study how matter is distributed in the universe. By observing how galaxies cluster, scientists can formulate theories about the large-scale structure of the cosmos, almost as if they were exploring a map of an unknown territory. With advances in technology, simulations are becoming increasingly sophisticated. Today's supercomputers allow for processing large amounts of data in a short time, meaning scientists can conduct more detailed and accurate simulations than ever before. This opens new doors to astonishing discoveries that could change our understanding of astronomy. Finally, as we observe how these simulations reveal the dance of galaxies in the vast universe, it is easy to feel awed. Each collision, each merger, each transformation reminds us of the immensity and beauty of the cosmos. Galaxies are like a grand canvas where stories of creation and destruction are painted, and we, through science, are beginning to understand those narratives. What new wonders will the future of astronomy hold for us? The answer, perhaps, lies in the algorithms and simulations that are shaping our understanding of the universe today. How do we know what happens in galaxies if they are so far away from us? The answer to this question is fascinating and reveals the creativity and ingenuity of humanity in its quest for knowledge. Astronomers use a variety of methods and technologies to observe and study galactic collisions, and each of them offers a unique perspective on our vast universe. Light, the same light that illuminates our daily lives, plays a crucial role in astronomy. When we observe the night sky, what we are really seeing is the past. The light from stars and galaxies travels unimaginable distances to reach our eyes. In fact, some of the galaxies we see today may have completely transformed, but we do not know because their light is still on its way. With powerful telescopes, scientists can capture this light and unravel the secrets of galaxies, even those that have collided. Optical telescopes are like large eyes looking into the universe, but there is more than just visible light. Galaxies emit radiation at different wavelengths from infrared to X-rays, so in addition to optical telescopes, we use radio and X-ray telescopes. This allows us to see galaxies in ways we never imagined. For example, X-ray telescopes can detect the remnants of galactic collisions, revealing the energy released during these cataclysmic events. What happens when galaxies collide? The answer is that enormous amounts of energy and gas are released. But how can we know that this has occurred? This is where computer simulations come into play. Scientists create virtual models of the universe where they can simulate galactic collisions. This not only helps them understand what happens at the moment of the collision, but also allows them to predict the future of the involved galaxies. It's like having a cosmic time machine where they can observe the past and future of galaxies. Technology has advanced impressively in recent decades. Space telescopes like Hubble have revolutionized our understanding of the cosmos. By being above the atmosphere, they can capture clearer and more detailed images of galaxies, allowing us to observe collisions and mergers from a unique perspective. The images we obtain are true works of art, where vibrant colors and intricate shapes tell us stories of cataclysms and creation. Through these observations, astronomers have discovered that galactic collisions are not rare events. In fact, they occur more frequently than we might imagine. Every time we observe a distant galaxy, we may be seeing the result of a collision that happened millions of years ago. It's like watching a movie where the action scenes were filmed eons ago, but the excitement is still present. Observations are not limited to large galaxies. Dwarf galaxies, which are much smaller, also play an important role in this process. As they interact with larger galaxies, they can be pulled apart and stripped of their material, affecting their evolution. Telescopes allow scientists to study these interactions and understand how each galaxy contributes to the fabric of the universe. But how do scientists ensure that what they see is accurate? The answer lies in repetition and analysis. Data from multiple telescopes are combined to create a more complete picture. This synergy between different observatories and technologies helps astronomers confirm their findings and build a more accurate image of galactic collisions. Sometimes the universe surprises us. There are phenomena that challenge our understanding and require new theories to explain them. How can two galaxies which seem so far apart influence each other? This type of question drives scientists to continue investigating, using increasingly sophisticated tools to unravel the mysteries of the cosmos. As technology advances, so does our ability to observe the universe. More powerful and sensitive telescopes are being developed, promising to reveal even more secrets about galactic collisions and other cosmic phenomena. The arrival of new space telescopes will open an even wider window into the universe, allowing us to explore the unknown like never before. International collaboration is also key in this process. Astronomers from around the world work together, sharing data and findings. This global community is a testament to human curiosity and the desire to understand our place in the universe. By joining forces, they can make discoveries that would otherwise be impossible. Science is not just about data and numbers, it is also about telling stories. Galactic collisions are an integral part of the universe's narrative. Through observation and simulation, we are writing a chapter about how galaxies intertwine and evolve over time. Ultimately, the study of galactic collisions not only provides us with information about the universe, but also helps us reflect on our own existence. Each collision, each merger is a reminder that everything is in constant change. Just as galaxies transform and evolve, so do we, on a continuous journey through space and time. What if I told you that the fate of Earth is linked to galactic collisions occurring in the vast universe? Although it may seem like a distant and abstract concept, these cosmic interactions can have a significant impact on our existence. From the formation of new stars to the alteration of galactic structures, collisions in space are events that can completely change the dynamics of the cosmos. But how could something so distant affect us here on our small planet? Galaxies, those immense collections of stars, gas and dust, are constantly in motion. In the vast ocean of the universe, they move like ships in a starry sea. When two of these giants cross paths, the energy released is monumental. However, most of the time, these collisions are not like the ones we imagine in action movies. Despite the enormous number of stars involved, the space between them is so vast that often the stars do not collide with each other. But then, how can this influence Earth? During a collision, gravity plays a fundamental role. As two galaxies approach each other, their gravitational forces can attract clouds of gas and dust, creating conditions favorable for the formation of new stars. This is a fascinating process that could, in theory, give rise to new lights in the night sky that we observe from Earth. What if one of those new stars were a solar system similar to ours? Such events remind us that the universe is a dynamic and ever-changing place. The history of the universe is full of collisions and galactic mergers. Each of these has contributed to the creation of the environment we know today. While these collisions occur on timescales that are difficult to comprehend, the effects can be long-lasting. Can you imagine witnessing an event as monumental as the merger of two galaxies? Although we cannot see these events in real time, astronomers have observed their traces in the sky, providing us with clues about what might happen in the future. The merger of galaxies can also have unexpected consequences. As galaxies intertwine, their shapes and structures can change dramatically, creating new configurations that alter the landscape of the universe. However, it is not just about the aesthetics of the cosmos. These interactions can influence the formation of new stars and, consequently, the creation of new planetary systems. Some of those stars could even host systems similar to ours. This leads us to the question, could we not be alone in the universe? An intriguing aspect of galactic collisions is how they can affect the interstellar medium, the space that exists between stars. By releasing large amounts of energy and matter, these interactions can trigger a series of events that alter the chemistry and physics of the galactic environment. This could influence the formation of planets and, in the long run, the possibility of life. Is it possible that collisions in distant galaxies are sowing the seeds of life in other corners of the cosmos? Although Earth is billions of light years away from these events, the connection is undeniable. The conditions that allowed life here could be influenced by galactic collisions that occurred eons ago. Every star we see in the sky could have a rich story, a story intertwined with that of our galaxy, the Milky Way. This makes us reflect on our place in the universe and how, in a cosmic sense, we are part of a much larger whole. As we advance in our understanding of the cosmos, technology and science allow us to observe and study these phenomena in greater depth. Telescopes and computer simulations give us a clearer view of what happens during these collisions. However, there is still much to discover. What mysteries does the universe hold for us in the future? Each new observation could reveal an unknown aspect of how galactic collisions have influenced life on Earth. The study of galactic collisions is not limited to science. It also touches our culture and imagination. From ancient mythologies that speak of gods and stars to contemporary works of art that represent the vastness of space, the idea of galactic collisions has inspired generations. It reminds us that although we are small compared to the universe, our stories and experiences are intrinsically connected to the immensity of the cosmos. Ultimately, the impact of galactic collisions on life on Earth is a reminder that our planet is the result of a continuous cosmic process. The history of our existence is intertwined with the dance of galaxies in the sky. As we continue to explore the universe, each discovery brings us a little closer to understanding how these interactions have shaped not only our environment but also our identity as human beings. So, the next time you look up at the starry sky, remember that every star you see and every galaxy you observe has a story to tell. The beauty of the universe is filled with chaos and order, with collisions and creations. And although we are in a small corner of this vast cosmos, we are connected in ways we are just beginning to understand. The story of galactic collisions is, ultimately, the story of our own place in the universe. Galaxies, those vast and mysterious collections of stars, gas, and cosmic dust, have fascinated humanity since time immemorial. They are not only objects of study for astronomers, but have also inspired myths, legends, and works of art throughout history. How is it possible that such a distant and complex phenomenon has left such a profound mark on our culture? The answer is intertwined with our need to understand our place in the universe. Since ancient Greece, constellations and celestial bodies have been a source of inspiration for storytelling. Galaxies, often seen as pathways of light in the night sky, have been interpreted in various ways across different cultures. In Greek mythology, for example, the Milky Way was considered a river of milk spilled by the goddess Hera. These narratives not only explain the celestial phenomenon, but also reflect a human attempt to make sense of the unknown. The influence of galaxies goes beyond mythology. In literature, authors like Jules Verne and H.G. Wells have explored the idea of life on other worlds, raising questions about the existence of civilizations in distant galaxies. These tales not only entertain but also invite us to reflect on the vastness of the cosmos and our own existence. What would it mean for us to discover that we are not alone in the universe? Art has also found in galaxies an inexhaustible source of inspiration. Painters like Vincent van Gogh, in his famous work Starry Night, captured the essence of a starry sky that seems to come alive. The way galaxies intertwine and swirl in space has been interpreted as a cosmic dance, a ballet of light and matter that awakens human imagination. Can art be a bridge between science and human experience? Galaxies not only captivate us visually, but also make us question the future. In science fiction, the idea of galactic collisions has been a recurring theme, presenting scenarios where entire civilizations must deal with the possibility of a cosmic cataclysm. These stories reflect our fears and hopes, leading us to ask, what would we do if faced with an event of such magnitude? The impact of galaxies on popular culture is not limited to literature and art. In cinema, films like Interstellar have shown us how journeys through space and time can become a reality, exploring the implications of galactic collisions in a narrative context. These works not only entertain but also foster interest in astronomy and science in general. How many people have been inspired by these stories to become astronomers or scientists? Music has also found its place in this context. Contemporary composers have created works that evoke the vastness of space and galaxies. The symphony of sounds can transport us on a cosmic journey, making us feel the grandeur of the universe and our small part in it. Can music be a way to understand the incomprehensible? Throughout history, galaxies have been a symbol of the unknown. They have represented a challenge for science, a mystery waiting to be unraveled. Human curiosity has led us to build telescopes and send probes into space, seeking answers about our place in the cosmos. The question of whether there is life in other galaxies remains one of science's great enigmas. What discoveries await us in the future? Galaxies have also been a subject of study in philosophy. Philosophers have debated the meaning of the universe and our existence within it, using galaxies as an example of the vastness and complexity of reality. These discussions lead us to explore our relationship with the cosmos and to question our understanding of life itself. Is the universe a random place, or is there a purpose behind it all? The study of galaxies has contributed to our understanding of the history of the universe. Each collision, each merger, tells us a part of the cosmic story. As we immerse ourselves in this narrative, we begin to see ourselves as part of a greater whole, connected to the universe in ways we never imagined. Isn't it fascinating to think that we are the result of processes that have occurred over billions of years? Galaxies, in their essence, are a reflection of our own quest for knowledge and meaning. They invite us to look up, to question what we see, and to marvel at the unknown. In a world so full of uncertainties, astronomy offers a sense of wonder and hope. Isn't it wonderful to think that despite everything, we are capable of understanding and exploring our cosmic environment? The study of galaxies also reminds us of the fragility of our existence. Our planet, located in a corner among billions of stars, makes us aware of the need to care for our home. Stories of galactic collisions can be frightening, but they also teach us about resilience and the capacity for adaptation. How can we apply these lessons in our daily lives? The influence of galaxies on modern culture is undeniable. From video games to theatre productions, the universe and its mysteries continue to inspire new generations. The curiosity for the unknown drives us to explore, to learn, and to create. What new stories and discoveries await us on the vast horizon of galaxies? Finally, the connection between galaxies and human culture is a reminder that, despite our differences, we all share a longing to understand the universe and our place in it. The stories of galaxies are not just distant tales, they are part of our own narrative as a species. Are we ready to continue exploring and dreaming of what lies beyond? The answer undoubtedly is in our hands. In the vast cosmos, the study of galaxies and their collisions stands at a fascinating crossroads. How could advancements in research change our understanding of these majestic structures and their behavior? The answer to this question lies not only in the present, but also projects into the future of astronomy. Astronomy has come a long way since the times when stars were observed with the naked eye. Today, astronomers use powerful telescopes and advanced technologies to delve into the secrets of the universe. However, when it comes to galactic collisions, the challenges are even greater. How can we study phenomena that occur millions of light years away? The key lies in technological advancements. Next-generation telescopes, such as the James Webb Space Telescope, allow us to observe the universe in different wavelengths, revealing details that were previously invisible. This opens a new chapter in the exploration of the cosmos. Computer simulations have revolutionized the way we understand galactic collisions. Scientists have created models that simulate how galaxies interact and collide over time. Imagine a video game where you can control the movement of galaxies. These simulations enable researchers to predict the behavior of these enormous structures and their interactions. What would a galaxy collision look like from the inside? Simulations not only provide us with a visual perspective, but also help astronomers make predictions about how galaxies might evolve in the future. The study of galactic collisions is not limited to observations and simulations. International collaboration among scientists from different countries has also led to an increase in the sharing of information and resources. This cooperation is yielding results in the form of massive databases that collect information about galaxies and their interactions. What surprising discoveries could arise from these joint efforts? The answer could change our view of the universe. The future is also filled with space missions that promise to provide more information about galaxies. Projects like the Euclid Space Telescope, which aims to map the structure of the universe, will provide valuable data on how galaxies are distributed and relate to one another. Can you imagine having a map of the universe that shows the trajectories of galaxies? That is the ambition of scientists, and the results could be astonishing. As we move forward, artificial intelligence is becoming a powerful tool for analyzing astronomical data. Algorithms can identify patterns in the data that may be invisible to the human eye. What secrets do galaxies hold that we have yet to discover? Artificial intelligence could help us answer that question by unraveling the complexity of galactic interactions. Education also plays a fundamental role in the future of galactic study. As more people become interested in astronomy, new ideas and approaches emerge. Online platforms and social media have allowed amateur astronomers to share their observations and findings, enriching the field. How can astronomy enthusiasts contribute to scientific research? Their passion and curiosity can lead to unexpected discoveries. The future of astronomy is not limited to observation and simulation. With technological advancements, new methods for studying galactic collisions are being developed. For example, spectroscopy, which analyzes the light from celestial objects, can provide information about the composition of galaxies and their activity. What revelations could arise from the light emitted by galaxies during collisions? The answers could unveil the history of our universe. Questions about the future of galactic collisions are endless. How will these events affect the formation of new stars and planets? What implications will they have for the overall structure of the universe? As scientists continue to investigate, they are likely to answer these questions and uncover new mysteries. The study of galaxies and their collisions also offers us a broader perspective on our place in the universe. As we better understand how these interactions work, we can reflect on the very nature of existence. What does it mean to be part of a constantly changing cosmos? The answers to this question may be as astonishing as the universe itself. As we look to the future, it is vital to remember that each discovery is another step in the quest for knowledge. Astronomy is a constantly evolving field, and each advancement brings us a little closer to understanding the secrets of the universe. What wonders await us in the future? With every question that arises, a door opens to new explorations and discoveries. The history of astronomy is filled with milestones and advancements, but also with uncertainties and mysteries. Each new technology, each international collaboration, and each discovery by an amateur astronomer pushes us to question what we know and explore the unknown. In the end, the study of galactic collisions is not only a scientific pursuit, but a reflection of our curiosity and desire to understand the cosmos that surrounds us. The future of galactic study is exciting, full of possibilities and potential. As we enter this new era of astronomy, each of us can be part of this cosmic adventure. Who knows what discoveries await us on the horizon? The only certainty is that the exploration of the universe will never cease, and there will always be more questions to answer. The universe, that vast ocean of mysteries and wonders, leaves us with countless questions that invite us to explore beyond our everyday perception. What does the cosmic dance of the galaxies truly teach us? In this journey through space, we have discovered that the collision between galaxies is not just a spectacular phenomenon, but a lesson about creation, transformation, and the connection between all elements of the cosmos. When we observe the night sky, we often think of stars as individual entities. However, each of those bright dots is part of a galaxy, an immense collection of stars, gas, and dust bound together by gravity. The beauty of these structures is astounding, but their history is even more fascinating. Galaxies are like great cosmic cities that have evolved over billions of years, and the collisions between them are events that transform their landscape. What happens when two of these cosmic cities meet? Galactic collisions are like two freight trains crossing at high speed. The outcome is not always destruction. Sometimes from the collision, new stars and solar systems are born. This process, which may seem chaotic, is actually part of the natural cycle of the universe. Matter, in its quest for balance, reconfigures itself, creating something new and vibrant. It is often thought that galactic collisions are rare events. But in reality, they are quite common in the vast stage of the universe. Gravity acts as a conductor, guiding galaxies in their cosmic dance, and these interactions are fundamental to their evolution. Have you ever wondered how stars are formed? Galactic collisions are often the catalyst for this process, bringing together the gas and dust necessary to create new stars. In this context, dark matter plays a crucial role. Although we cannot see it directly, its influence is felt in every corner of the universe. It acts as an invisible glue that keeps galaxies together and guides their movements. Without it, the universe would be a very different place. Imagine a puzzle without the central piece that holds it together. That is what the cosmos would be without dark matter. Looking ahead, the imminent collision between the Milky Way and Andromeda is a reminder that our home is also in constant change. Within billions of years, our galaxies will intertwine, creating a new stellar environment, but there is no need to fear, as life on Earth as we know it will likely have changed significantly by then. However, this vision of galactic merger invites us to reflect on our place in the universe and on the time that unites us all. Dwarf galaxies, often considered the small towns of the universe, also have a role to play. By interacting with larger galaxies, they can influence their evolution and growth. This aspect highlights a fundamental truth. In the cosmos, every element, no matter how small, matters and has an impact. Interconnection is an essential feature of the reality we inhabit. As astronomers continue to observe and study these phenomena, The use of computer simulations has revolutionized our understanding of galactic collisions. These tools allow scientists to visualize in 3 dimensions what happens in space, offering a window into events that occur on time and distance scales that are unimaginable to us. It helps us understand that, although we are on a small blue planet, we are part of a vast and dynamic universe that continues to evolve. The history of the universe is filled with collisions and mergers, from the early days after the Big Bang to the events that shape galaxies today. Each collision tells a story, and each galaxy has a past that defines it. When we look to the stars, we do not just see light, but the very history of creation itself, a tale that has been woven over eons. Finally, it is fascinating to think about the impact that these cosmic events can have on life on Earth. Although it may seem that we are in an isolated corner of the universe, the dance of the galaxies can influence our destiny. Understanding these phenomena invites us to consider how the cycles of the cosmos may reflect in our own lives and societies. Thus, as we conclude this exploration of galaxies and their collisions, it is clear that the universe is a place of beauty and chaos, of destruction and creation. It reminds us that although we are small in the vast immensity of space, each of us is part of an interconnected whole. The galaxies, in their diversity and complexity, teach us about the importance of collaboration, transformation, and the continuity of existence. Ultimately, they leave us with a question that resonates through time. What new wonders does the future hold for us in this immense and astonishing adventure that is the universe?